Hello, welcome to progressive class under indices. In previous classes, we have proved the laws of indices and we have tried to get ourselves familiarized with the laws of indices. Remember, I mentioned in the last class that in subsequent classes like this, we wouldn't have to be writing the laws of indices on the board again. By now, I expect you to have gotten yourself acquainted with those laws. So let us try to apply those laws without looking at them, because that's exactly what you are going to do in your exam. I have an example here, and this is a WAEC standard question, a past question. So we'll begin to work with that now and see how well we can apply what we have learned under the laws of indices. So the question we have here, we have been asked to simplify this. So the first thing is that you need to take like 2 seconds to look at this question. This is 4, can be expressed as the power of 2. You go to the lowest base that a number can be expressed in. 4 can be expressed as power of 2, 8 can be expressed as power of 2, 16 can be expressed as power of 2. 2 is already in the lowest base number. So I can say that, okay, in our culture, let us write solution. Then I can have the question here again, 8 squared 4n raised power n minus 1, n plus 1 rather, 2 raised power 2n multiplied by 16. And then I can transform this to be 8 can be written as 2 raised power 3, okay, bracket this 2 that is here, which is the square, multiplied by 4 can be written as 2 raised power 2, and then bracket n plus 1, that is already the power, okay, n plus 1, and then I can have all over 2 raised power 2n times 2 raised power 4. 16 is 2 raised power 4. So I can begin to sort them out by saying that 3 times 2 will give me 2 raised power 6 times 2, 2 times n, 2n, 2 times 1 plus 2, then all over this. I can sort it out already, the same base. So you remember the law, when the same base multiply, I will choose 1, then I will have 2n, multiplication will become addition, and that will be what? Plus 4. Let's continue here, and then I can say that that gives me, okay, that gives me 2 raised to power 6. Don't bother to say you are multiplying and coming back to bigger number again. In indices, we are interested in simplifying big numbers into index form. So don't make it complicated by having 2 raised to power 4 and immediately you just want to turn 2 raised to power 4 to 16. No, you should focus on the big numbers and how you can break them into their index form. So we have 2 raised to power 6 there, the same base number, okay. So I'm going to choose 1 plus this multiplication is the one that become plus what? I have 2n plus 2, and then all over what I have here, 2 raised power 2n plus 4. I hope you have gone through our like terms class under linear equation, because that will help you. For example, here you cannot say 2n plus 4. They are not same term. And here, you just look at it. Is there anything that is of the same term here? This is ordinary 6 and this is ordinary 2. So they can add together. So I will have 2 raised power 6 plus 2 will give me 8. Then plus 2n. That 2n cannot add up to it, divided by 2 raised power 2n plus 4. So I can say that I have root 2 raised power 8 plus 2n. This line here means division. That's divided by 2 raised power 2n plus 4. So I can now say that square all roots, I have 2 raised power 8 plus 2n Division will turn to minus. Be careful, since you put this minus and you see that this is just not 1, that minus is for both of them. So you have to put them in bracket. Plus 4. Okay? And then I will have 2 raised power 8 plus 2n minus times 2n minus 2n minus times plus 4 minus 4. That's what I will have. And then I will go with things of like terms. Plus 2n minus 2n. 2n, 2n. Okay, n is there, so they are of the same term, so I can treat them. But plus 2n minus 2n, if you have gone through our previous classes under that, you know that this will become 0 to cancel out. Okay, and then I will have left here, what I will have left there is 2, 8 minus 4. 8 minus 4 will give me what? 4. And then now that I have a single index number, I want to check if it's a perfect square so that I can actually work it out. Or you may say that let's still apply the loss of indices without turning back to a big number. So you can say 2 raised power 4. This square root here simply means 1 over 2. You remember that law. You may still check the law if you are beginning to forget it, but I hope you have learned it by heart like I recommended in the last class. This 2 here, okay, is the one that becomes square root here, okay, and this 1 here is just power of 1, which we don't have to write. So root 2 raised power 4 means the same thing as 2 raised power 4 bracket raised power half. So I can easily say that 4 times half, it's just like having 4 times 1 over 2. Okay, maybe I should write it here so that for now we are just beginning to solve questions. So let's take it easy. So that will be 2 here 1, 2 here 2, and that will give me that what the remaining thing there will be what 2 raised power 2. 2 raised power 2 will give me what 4, and that will be our final answer. So this is the approach. Okay, just try to apply the law, try to learn the laws by heart and try to apply them. The more you use them, the more you get acquainted with them. In the next class, we'll be solving more questions, WAEC questions, JAMB questions, A-level questions, and in every examination where we may have what indices of this form for using the laws of indices. We'll try to sample questions from all these past questions so that everyone on this channel can be carried along. My name is Mr. Legend, and I will see you in the next class. Try to share out this video, comment, share, learn, and let me know how well you are doing with your mathematics skills under indices. Bye for now.